So these are your essays back. For you. For you. Okay, so in these essays, I was asking you to compare ventricle to the essay node. They're all pretty good, but I just highlighted some of the points. So particularly where you're lacking a little bit is in some of the clinical aspects and their relevance. But we'll kind of cover that today because we'll be talking about arrhythmias and antiarrhythmic drugs as well. So that's kind of our classic nerve. Why don't, if you stimulate the nerve, why can't it go backwards then?
Because the membrane region behind the kind of newly stimulated region is refractory, so the sodium voltage gated channels remain inactive, so they can't be activated again until after a certain period of time or resting membrane potential is achieved again.
Yeah, exactly. So you can never go backwards because the sodium channels are effectively out of action. This is a very different action potential from what we see in other cells. Does anybody come across any experiments?
I did.
In your essay?
So this was the evidence for the funny current. So originally they didn't know what was happening. So they did experiments on rabbit sinoatrial nodes where they stimulated with adrenaline and saw that the change in voltage could not be accounted for by simply potassium flux and calcium flux in the cells. So they postulated there could possibly be another channel at play. So in order to try and prove this, they voltage clamped the cells at very negative voltages, and saw that voltage would then pulse away from that, so it was constantly trying to move up, and they found that this was then proportional to the current flowing through the HCN channels, which are responsible for the funny current, which proved the existence of the funny current.
Yeah.
Why did they say that the negative voltages can't, like the change in PD can't be due to sodium?
Once you measure all the currents going through the potassium channels and the calcium channels, you can calculate then the change of voltage that would be associated with that, and it was not in keeping with what they were measuring experimentally when they were stimulating SA node cells with adrenaline.
So, one of the important things we want to do is look at the electrical activity in the heart, because that will tell us about what might be causing possible pathologies. How do we monitor the electrical activity in the heart?
We can monitor it with an ECG.
We can. ECG. Alright, how do ECGs work?
They measure the current on the cell, on your surface, like skin surface, from, I don't know, someone else who, I do know, I don't know how to say it.
So the electrical activity in the heart can be detected at the skin surface.
Yeah.
So therefore you can place electrodes on the skin surface to detect the changes in electrical activity that are occurring within the heart during the cardiac cycle. Okay. So therefore the normal one is a 3-lead ECG, where you have one lead going that way and another lead going that way, which creates a focal point with the heart in the middle, which means you can view the heart from 3 separate directions.
Yeah, so exactly right. So we classically, if we were in casualty, then that's classically a 3-lead ECG. So it gives you even a 3-lead will give you a lot of information about the heart. But what is it not telling you about the heart? So it's telling you about the electrical activity.
It doesn't give you any idea of because it's just from one surface. It doesn't give you any idea of the sort of depth that you're looking at, which is what you can get from 12-lead ECG, because it goes transverse across your body as well.
Depth.
So
it's like frontal.
Looking in the
So 3-lead only looks
in
that way.
the coronal plane.
Yeah.
But that's solved with the 12-lead, because 12-lead will look anterior
around
look in the transverse.
but will look anterior.
Yeah.
Say you want to be an extra in casualty.
Yeah.
For the ECG heart attack part.
Yeah.
Okay.
You criticise that technique because it's a...
Well, you could do that, yeah. So you've got a person you're like, Mr. Bloggs can be amazing for the ECG, check it out. And they're like, Mr. Bloggs is completely unconscious. He's got perfect ECG. What could be wrong? What information? You know about the electrical activity, but what don't you know about from an ECG?
Whether there's any obstruction, what the blood flow is like.
Yes, you don't know anything about whether it's actually pumping or what the pumping is like.
So it's a prolongation of a normal action potential, but then can lead to arrhythmias like ventricular fibrillation.
Yeah.
By the re-entry of currents causing fibrillation.